Picture this. You're standing on the edge of a precipice, and beyond that edge lies the most mysterious and powerful force in the universe. A place where the laws of physics break down, where time and space lose all meaning. It's a place that has captivated the minds of scientists, philosophers, and dreamers alike. A place where gravity is so intense it can swallow entire stars, planets, and even light itself. That place is a black hole. We're going to journey into the heart of the universe's darkest and most enigmatic phenomenon. We'll uncover how black holes are born, what makes them so terrifyingly powerful, and what happens if you dare to venture too close to one. But first, let's start with the question on everyone's mind. What exactly is a black hole? In simplest terms, a black hole is a region in space where gravity is so strong that not even light can escape. But to fully understand what a black hole is, we need to take a closer look at how gravity works in the universe. Gravity is the force that pulls objects toward one another. It's what keeps us grounded on Earth and what causes the planets to orbit the Sun. But gravity isn't the same everywhere. It's much stronger around massive objects, like stars, planets, or black holes. The genius of Albert Einstein's theory of general relativity revealed that gravity doesn't just pull on objects. It bends the very fabric of space and time itself, like a heavy ball placed on a stretched rubber sheet. The larger the object, the more it distorts space-time. Now, picture this. A massive star, hundreds of times heavier than our Sun, runs out of fuel. Without that energy to support it, the star's core collapses under its own weight. As the core continues to collapse, it forms a singularity, an infinitely dense point in space. Around this singularity, space and time are warped so drastically that not even light can escape its pull. This is what we call a black hole. The point of no return around a black hole is called the event horizon. Once you cross that threshold, you're gone. There's no coming back. Let's dive deeper into how a black hole forms. To understand this, let's look at the death of a star. Stars live out their lives burning hydrogen in their cores. This process creates an outward pressure that balances the inward pull of gravity. But when a star runs out of fuel, it can no longer fight the gravitational pull. If the star is massive enough, its core contracts under the pressure of gravity and the outer layers expand outward. Eventually, these outer layers are ejected in a violent explosion known as a supernova. If the remaining core of the star has enough mass, typically about 3 times that of the Sun, gravity takes over completely. The core continues to collapse until it becomes a singularity, forming a black hole. This is when the event horizon forms, a boundary beyond which nothing can escape the black hole's gravitational pull. Not even light, which is why we call it a black hole. But not all black holes are created equal. In fact, there are 3 main types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. First, we have stellar black holes, the most common type. These are formed when massive stars collapse, as we just discussed. Their masses range from about 5 to 20 times the mass of our Sun. Next, we have supermassive black holes. These monsters lurk at the centers of most galaxies, including our own Milky Way. These black holes are millions to billions of times more massive than our Sun. We don't fully understand how supermassive black holes grow to such enormous sizes. Some scientists believe they form through the merging of many smaller black holes, or by pulling in massive amounts of gas and dust over billions of years. Finally, we have intermediate black holes, which are more mysterious. These black holes have masses that range from 100 to 1,000 times that of our Sun. While we've detected a few candidates for intermediate black holes, they're still incredibly hard to study. Intermediate black holes might be a crucial link in understanding how supermassive black holes come to be and how they evolve over time. Now, let's talk about what happens when you get too close to a black hole. The most important feature of a black hole is its event horizon. It's the point beyond which nothing, not even light, can escape. But what happens to objects that cross this boundary? Well, this is where things get really bizarre. As you approach a black hole, the gravitational pull grows stronger and stronger. And here's where the fun begins. This is what we call spaghettification. Spaghettification is the process where the gravitational forces from the black hole stretch an object, like a human or even a spaceship, into a long, thin shape. It's like getting pulled into an enormous cosmic noodle. Here's why it happens. As you get closer to the black hole, the difference in gravitational pull between your head and feet becomes extreme. The force acting on your feet is much stronger than the force acting on your head, causing you to stretch out. It's a brutal process. Your body would be pulled apart by these extreme forces. But don't worry, there's no black hole anywhere near us. The closest known black hole is over 1,000 light-years away. Still, it's mind-boggling to think about the power these objects wield. So, how do we know black holes exist? If they're invisible and impossible to see directly, how do scientists spot them? It's all about observing how black holes interact with their surroundings. For instance, when a black hole pulls matter from a nearby star, that matter heats up as it spirals toward the black hole's event horizon. This creates powerful X-rays that can be detected by space telescopes. This is how we first discovered stellar black holes. By watching how stars orbit an unseen object, scientists can infer the presence of a black hole based on its gravitational influence. In recent years, we've made another breakthrough: gravitational waves. These ripples in space-time are produced when massive objects, like black holes, collide. In 2015, scientists at LIGO detected gravitational waves from a black hole merger, confirming the existence of black holes in a whole new way. Now, let's zoom out for a moment and look at the big picture. What role do black holes play in the grand scheme of the universe? Supermassive black holes are found at the centers of nearly all large galaxies. In fact, many scientists believe that these black holes may play a key role in the formation and evolution of galaxies themselves. It's possible that black holes help regulate star formation by controlling the amount of gas in the galaxy. Without black holes, galaxies, maybe even our own, might look very different. They could be less stable, with fewer stars and perhaps no life at all. In a way, black holes may be shaping the universe on a grand scale. So, what's next for black hole research? Well, the future is incredibly exciting. As technology improves, we're getting closer to unlocking the secrets of these cosmic giants. One of the most exciting projects is the Event Horizon Telescope. In 2019, scientists using this network of telescopes captured the first ever image of a black hole. It was a groundbreaking moment in astronomy, allowing us to see the shadow of a black hole for the very first time. The next step? Better and more detailed images, more data, and maybe even answers to the big questions. What happens inside a black hole? Can we ever hope to study a black hole up close? Black holes are undoubtedly one of the most fascinating mysteries in the universe. From their formation to their role in shaping galaxies, these cosmic giants hold many secrets, and we've only just begun to unlock them. Thank you for joining me on this journey through the darkest corners of space. If you enjoyed this video, don't forget to like, subscribe, and leave a comment down below. What do you think is the biggest mystery of black holes? Until next time, keep looking up, because the universe is full of wonders yet to be discovered.